Okay, so we are looking at the beginning of section 3.3 in the workbook, which is page 71. And in this section, we are going to be talking about finding absolute maximum and minimum values of a function. Okay, just to give you a little background as to why we might be interested in a problem like this, maxes and mins come up in a lot of different applications. For example, maybe if you're a business person, you might be interested in figuring out, how do I maximize my profit? What do I charge for the product that I'm manufacturing to maximize profit? Or maybe you're interested in minimizing your operating costs, okay, in order to maximize profit. If you were a car maker, maybe you're interested in maximizing fuel efficiency or something like that. All of these problems come down to having a function and being able to find a maximum or a minimum point for it. Okay, so what we're going to describe is a way of finding maximum and minimum values, starting with a bit of a graphical discussion here. All right, so this preliminary example that they're giving us, they give us the graph of a function and ask us just to graphically locate a few points. Okay, in particular, they'd like us to locate local and absolute maxes and mins. Okay, and this is a good chance to just review what those terms are telling us. So an absolute max and a min are just the highest and the lowest points on your graph. So if you look at this whole graph and ask, where is the highest point? Sitting right over here at the very right. That would be our absolute max. Okay, and the very lowest point on the graph is sitting here. Okay, at x equals 7, it looks like. And do you see any local maxes and mins for this function? I see a few. For example, there's a local max sitting about here. And there are a couple of local mins here and here. Those are valleys. Okay, one of those local mins is at a place where we also have our absolute minimum. Okay, and so we could ask the question, what is special about those points that we've just located? Okay, well, they didn't specifically ask us about critical points, but notice that there's a little bit of a correspondence between where some of these maxes and mins live and where we have critical points. Okay, so a critical point, again, is a place where the slope is 0, and you might notice that there are 3 places like that if you draw in tangent lines. We've got critical points at x equals 2, it looks like, then again here. Okay, at x equals, I don't know, maybe 3.7 or 3.8, and then one last one at x equals 7 here. Okay, what we'd like to do is to see if we can take all of that information and kind of fill in this general rule that they're giving us. This is going to give us a way to help us to find absolute maxes and mins. Okay, this describes a process for us for finding the absolute maximum and the absolute minimum of a function. Okay, and it tells us that we really just need to look at 2 different places. We can maybe answer the question of where to look by looking at our graph. Okay, so if you look at where the absolute minimum is, that just happened to occur at a critical point. Okay, so that's one place that we're going to be interested in looking. The absolute max, on the other hand, is sitting over here at x equals 10. That's not a critical point because the derivative isn't 0 there, but what is special about that point is it's on the very end of our graph. So we could call that an endpoint. And it turns out that if your function is continuous on a closed interval, these are the only 2 places that you need to look. If you look at all of your critical points and all of your endpoints, you are going to find your absolute maximum and absolute minimum value.